Let's look at the product rule, and this is taken from section 2.3 in our textbook. Day 1, we are solely going to do product rule on day 1, and then day 2 we will work with a quotient rule. So the product rule, there's answers to yesterday's homework. There was a warm-up exercise to do the derivatives of these. What I would expect people maybe at this point to do is to just FOIL this out and get x squared plus an x minus 6, and then go in and do the derivative, which would be 2x plus 1. Fairly fast procedure, right? And I have to do that at this stage because all I know about is the power rule. Well, today we're going to pick up a thing called the quotient, or the product rule. And we can see how we've got two items multiplied here. So the product rule could be used on that, and we'll see an example like that when we go through it. This second one is really just to get you back in the mind frame of using the power rule. So the 4 comes down, multiplies by the 10, we get 40x to the third because we reduced the power by 1. On this next term, I think I would rewrite this as x to the negative 2. And now I take the negative 2, multiply it by negative 3, gives me a positive 6. X to the subtract 1 power from this, and I'm going to be at negative 3. So I would rewrite that equation, or that derivative, as 40x to the third plus 6 over x 3. So like I explained, we're going to work on the product rule. There is the product rule written in the textbook, and it's the theorem, and they give us the layout for how to do the product rule. Notice there is an addition between these two functions that we're going to be creating. And it starts out like d dx. This stands for take the derivative, or the derivative of two things multiplied, where I have one function times another function. And here we use the f and the g function. Well, the product rule goes like this. I'm going to take the derivative of f prime. Notice the prime symbol there. That means I'm taking the derivative of the first term, or expression, and multiplying it by the second expression, g of x. I add, and then now I reverse the scenario. I take the derivative of the second expression, which is our g of x, and multiply it by the first. So to myself, a lot of times I will just repeat this pattern over and over. The derivative of the first times the second, so first, and this was a derivative of the first times the second, plus the derivative of the second times the first. So if you like, memorizing kind of a phrase, it will work as you go through and do the product rule. Let's see. Let's go through problem A here. We can see that we have a binomial times a binomial, 2 terms times another 2 terms. We are not going to do it without the product rule. Let's just go ahead and do product rule. So this I'm going to assign to be my f function, and this as my g. And we remember, you have it up above. I'm going to rewrite this. The derivative of f times g, just shortening where I'm not throwing all those x's in now, it's going to be f prime times g plus g prime times f. And I've identified my f and g. So I get y prime equals the derivative of f, which would turn out to be 4 plus 2 times 2 is 4, and then I take the squaring and reduce it by a power to give me just an x to the first. This was f prime. Now what we need to do is multiply it by g. And g is 3x minus 5. Next comes the plus, and I go into the derivative of g prime. So now we're going to look at the second expression and take its derivative. Second expression is right here, 3x minus 5. The derivative of that would be simply 3, and I multiply it by f the expression f, and that was 4x plus 2x squared. That was my f function. There was a plus sign in between there. Okay, so that is the product rule. And the next thing that I would do is just try to simplify this. So we will end up foiling. I'm going to distribute my 4 and get 12x minus 20. And then I'm going to do my other distributive, take the second term and distribute it through. And that'll give me up 12x squared minus 20x. Finally, let's take the 3 and distribute it. I'm going to pick up 12x plus 6x squared. Look for like terms now, and let's put the squared terms together. That will give me 18x squared. Okay, I've taken care of those. 12x plus 12x would give me 24x. Subtract 20, and that leaves me a positive 4x. So those terms are gone. And finally, it looks like we have a minus 20. So y prime equals 18x squared plus 4x minus 20. On to example B. Now here is really a reason that we would need a product rule. I cannot simplify this like I could have on problem A. On problem A, we could have FOILed this out right away and got y written as a polynomial like what would have been 6, but 12x squared, dot, 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 and then taken the power rule on that. Had options on example A, but on example B, there's no way to simplify this. We are just stuck with the product of those two terms. So let's think of the sign as our f, and the square root of x will be my g. So the product rule is going to lay out f prime g plus g prime f, just following the rule for the products. And that would be f times g derivative. So I'm just going to say y prime equals, the derivative is equal to, first thing I got to do is take the derivative of f. The derivative of sine is cosine x multiplied by the second term as is, so square root of x. Addition, and then I want the derivative of g prime. Derivative of g, this would be x to the 1/2, so the 1/2 comes down, and I subtract 1 from 1/2 and I get negative 1/2, power rule. Multiply this by f, which is sine x. Let's just do a nice cleanup line here to make it look pretty. I'm going to bring my square root x in front, multiplied by cosine x. Plus 1/2, the 2 is in the denominator, sine is a numerator, and this term, x to the 1/2, will drop to the bottom. A 1/2 power means the square root. And you may leave your answer just like that. Letter C, I have a binomial times a trinomial, 2 terms times 3 terms. I could elect to distribute through, and pick up those 6 terms and then do the power rule. That would be fine. But since this lesson's about the product rule, let's go ahead and use the product rule. This first term will be my f, the second term will be my g, and now remember the pattern for product rule. F prime of x. And I've got a little bit of overlap here, don't I? But that's okay. I think we can keep track. You know what? I'll even change this. I can call this like a u and a v. The product rule is going to go derivative of the first multiplied by the second, add derivative of the second times the first. There's our product rule. So I need to take the derivative of u, which will be 3x squared minus 3, using the power rule on that expression, multiplied by the second expression as is. Addition comes next, and now I want to look at the derivative of the second term of my v term here. And that's going to be power rule. 2 comes down, multiplies by 2, gives us 4x. Plus 1 comes down, multiplies by the 3, gives us 3. X will go to a 0 power because we reduce the power by 1. The derivative of 5 will go to 0. Now I need to multiply it by u, which is our first term, x cubed minus 3x. There's the layout. It's basically done, but we'll want to simplify. So let's go ahead and do some distributing. And then I'll have to run this one through. So let's get that done. 3x squared times 2x squared will give me 6x to the 4th. Now I'm going to do the first times that middle term. I'll get plus 9x cubed. And the first times that very last will give me plus 15x squared. Now I'm focusing on my negative 3. Negative 3 times negative 2 is negative 6x minus 9x minus 15. There are the 6 terms from multiplying. On to these last two, I will pick up 4x times x cubed will give me 4x to the 4th minus 12x squared. 3 times x cubed will be plus 3x cubed. And this times that, 3 times negative 3 will be negative 9x. Look for like terms. Looks like our highest degree, the 4th powers. So I am going to end up with f prime of x equals 6 plus 4 is 10, x to the 4th. Got those done. I see some cubes, so I'm going to pick up my cubings. And I get 3 plus 9 gives me 12x cubed. Move on to the squared terms. I have 15x squared and a negative 12, so a positive 3x squared. X's, negative 6, negative 9, negative 9, so negative 18 minus 6, negative 24. X, done, 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 and minus 15. There's our simplified answer. On to example D. Do you see that this is the product of two things? It could even be thought of as the product of three things, but I think by lumping that first 3 times x squared together will pan out for us. It'll make it a little bit faster. All right, so I've got, we can go back to F and G. Well, we got G over here. Let's stick with our U times our V. So the product rule will say derivative of the first times the second plus derivative of the second times the first. G prime, let me switch ink. Here we go. G prime of x. Take the derivative of your first term, 6x, multiplied by the second, which will be cosine x. Add derivative of the second term. Derivative of cosine switches to negative sine x, multiplied by the first as is, which would be a 3x squared. Okay, essentially we're done. Let's just clean up, maybe reorganize a little. 6x cosine x sounds good. I notice I've got plus minus, so this will be a minus. I'm going to bring this to the front, 3x squared, and then multiply by sine x. And that is the finished answer. I guess if we wanted to, we could pick up, they both have a factor of 3 in common, and they both have an x. So I could GCF out 3x. That'll leave me a 2 cosine x in the first term. I took a 3 and I took an x, so I'm going to have minus x sine x. And then we're in factored form. Just do a mental check, redistribute, make sure that it is the same as what we had started with, the 6x cosine x. Looks good. And a 3x squared sine x. Problem E is a little bit different, just to give you a flavor of how else the product rule can kind of be tested. Notice we're given a lot of things. I'm given how h, the function h, is defined basically using 2 other functions that are multiplied. I'm also given some specific values. Some are just functions evaluated at 1. Others are derivatives evaluated at 1. So how would I find the derivative of h at x equals 1? Well, I'd look up here and see how the heck to create h. H of x is equal to f of x times g of x. Now, if I want to take the derivative of h of x, then I'm going to follow the product rule since I have two things multiplied. Derivative of the first times the second plus derivative of the second times the first would look like f prime g plus g prime f. I need to evaluate this at 1 is what it's asking, so h prime of 1 will now be f prime of 1 times g of 1 plus g prime of 1 f of 1. And all those values are going to come from looking up here, and capturing the values and just substituting them in. All right, I really have a mess up here. Let's clean this up. Okay. Final line, h prime of 1 is equal to f prime of 1 is a 3. G prime of, or g of 1 is 5. Plus g of 1, oh no, I'm sorry, it's g prime, isn't it? G prime of 1 would be 7 times f of 1. F of 1 is a 2. And that's pretty easy now, isn't it? Let's just go h prime of 1 is equal to 15 plus 14, which makes it 29. I kind of like those. Not as much work, really, because so many values are provided to you. Finally, the last thing is this example f. And you might say, ugh, when you see the box in green. What is that showing us? Well, it's showing us how to do the product rule when there are more than 2 factors. In this instance, I'm showing you 1, 2, 3 factors multiplied together, aren't I? The pattern will lay out like this. I take the derivative of the first function and multiply it by the regular g and the regular h function. Then I move on, and I take the derivative of the g function, multiply it by f original and h original. Then I move on. Notice addition is in between each of these ideas, and I take the derivative of h prime, multiply it by f and g of the original functions. So looking this over, I end up taking the derivative of f, I end up taking the derivative of g, and I end up taking the derivative of h. They all get a turn at having their derivative taken, and then multiply it by the other 2 original functions. So it's much like the 2-factor product rule, just extended. So this will be 1 factor. Here's another factor, and there's my third. I can think of this as f, g, and h. To do the derivative, it's going to look like f prime g times h plus g prime f times h. Finally, h needs a turn, getting its derivative, and then multiply it by the other 2 terms, h prime times f times g. That's the layout. Here we go. Probably take some paper, won't it? Okay, so f is x squared. Let's take its derivative, 2x. Got that done. Now multiply it by g and h just in their original state. So a cosine and a sine going down there. Add with it the derivative of g prime. G is the middle one. The derivative of sine is cosine x. Multiply it by f and h. F is x squared. H is cosine x. On to the third and final term. This time I get to take the derivative of the very last expression there, the cosine. And the derivative of cosine, remember, is negative sine x. And I multiply it by f and g. F was x squared, g was sine x. It's interesting. Now, what could we do? Well, there might be a little, I see some pulling together I could do. So let's make a line where we just make it a little more concise if we can. Sine x cosine x. Plus I'll get cosine squared. So I have that x squared. I'm going to put that in front because I can change the order of multiplication by the commutative property. So I get x squared times cosine squared. The plus minus will make this a negative. And sine times sine will give me sine squared. I'm going to, again, write the x squared first, and then I'll have my sine squared x coming in. And taking a step back, looking at this problem, they do all have an x in common. So if you wanted to factor in GCF and x, you could, and then write the rest of it down. But not a lot gained by doing that. So there's our answer. That covers the day 1 notes, and this is the homework. It is found on page 126, and if you would like, you could print this exact page. I put it as a PDF in your Schoology Chapter 2 homework file. So if you'd like to print it, please don't do your work on this page. You do not have enough space. Use some lined paper, keep things organized, and that's going to help you get these answers right. Also, I have posted the solutions or my answer key and shown my work for all the problems. So if you do get stuck, you could refer to that as well. So that answer key is in Schoology too. Hey, have a great day. Bye-bye.